Hello and welcome to Topological Queries and Analysis of School Buildings based on Building Information Modeling, BIM, using parametric design tools and visual programming to develop new building topologies. First of all, the basis on the technological side is the visions of the new tools in architecture of the 1970s. To be precise, the vision of Nicolas Negroponte's new tool, which needs to be fulfilled but hasn't been realized yet. The computer doesn't understand what the architect intends to design. But today's technology offers the application of artificial intelligence in architecture. Why school buildings? There's a rising number of school building in construction, renovation, and expansion. It is at the top of the list of the construction industry, categorized by tender procedures. Schools are the representative of the economical essence and ideals of a current economy. The international global competition for high-quality education and intellectual assets is essential. The paradigm of this paper are fingerprints of architecture. To formalize building information, it is proposed so-called semantic building fingerprints. These spatial fingerprints are, for example, adjacency and accessibility. The idea is to transform spatial configurations of schools like topological, semantic, and geometric information into readable form for a computer. It is to analyze buildings and use it as a case base for the generation of variations using deep learning. The architectural GraphML, or short AGraphML format, derived from the fluent graph format of GraphML, based on the XML format, is used to depict adjacency, accessibility, depth, flow, and the analysis of the room program in Rhino 3D, Grasshopper 3D, and Gephi in a readable visualization. The challenge is the complexity of schools and their floor plans. There are four main categories of influences and reasons for changes: historical and political context, social and cultural aspect, pedagogical influences, and architectural development. School buildings are the physical institution which serve as a framework to deliver the entity of a pedagogical concept to increase the intellectual development, the social upbringing, and cultural education. This leads us to the implementation. Here is a software workflow overview, and it pictures the different programs and plugins that are used to translate an IFC file format into an AGraphML format. Rhino.2020 from Autodesk is used to import the IFC file. Further, rhino.inside is developed based on the Rhino 3D7 work in progress. It allows extracting and working in real time with Revit elements in a parametric design tool Grasshopper for visual programming. Using multiple plugins such as Pufferfish, TT Toolbox, Kangaroo Tool, Panda, and Elephant to transform the available geometries into readable shape language, and also custom components for Rhino.inside to extract. The Grasshopper plugin Dolphin can translate Rhino geometries and then write them as an AGraphML internally, which can be printed with a Python component as an XML file. Now we come to the procedure workflow. First of all, you have the IFC space, as you can see, and then you need to extract using the Rhino.inside component. The next steps need to be taken simultaneously but apart from each other. So we have 3D objects that are turned into 2D objects and translated into readable shapes for the Dolphin plugin, while at the same time you extract the identities from the IFC space, evaluate this data, conform these terminologies into a dictionary that is set up using the 12 buildings of future school buildings by Freires and Commerel, and then assign these room names to the rooms. And finally, you merge all of this together in Rhino, which is then converted into the file format of AGraphML. And finally, it is written as an actual file on the desired path. And as a result, a rough topological analysis with Gephi can be conducted to identify structural patterns for school buildings as a basis to develop automatic machine learning approaches. This described workflow and process in Grasshopper was applied to IFC files of 3 different school buildings of the Architect's Office of ALN, Architekturbüro Leinhäupl Neuber GmbH. Due to this testing with these floor plans, the necessary conditions and restrictions were depicted and improvements in the visual programming were made. First patterns recognized by the architect is a correlation between space and size, such as the circulation area, which is very large and often connects with or is itself a multi-purpose area. Most of the floor plans include study clusters, and it becomes clear that the rooms open to the students are all quite similar in size and shape. But as the children can occupy all of them, the 4 square meters per student are achieved. There's a sequence succession of rooms starting at the Marktplatz and ending in the classroom. It is evolving from a large common room alternating to a classroom through a passage-like small room called inclusion or a supervision room, which can be accessed from both adjoining classrooms. Group rooms are always connected to at least one so-called Unterrichtsraum, English teaching room, which is different from a classroom. These group rooms take about half the area of a classroom or are equally sized to an Unterrichtsraum, thus providing, combined during projects, the amount of space of a classroom, maximizing the available square meter per student. The ground floor of school buildings with more than 2 stories is used solely for administrative and public rooms such as library, cafeteria, and first aid. And what does the future hold? The Dorfroom plugin is currently being improved for operability and more information input and ready to use output. After more testing and refining on a larger scale of floor plans, the pre-processed data is to be introduced to an artificial neural network to generate new architectural floor plans using deep generative modeling. The data can be used, for example, with a tensor data structure relation map for intelligent variant design according to predefined design requirements, and finally an auto-completion of building designs. Thank you for listening.